Right now, somewhere in space, an invisible wave of destruction is racing toward Earth at the speed of light. Scientists have discovered 10 cosmic nightmares that could end humanity without warning. We will journey to dead zones where aliens should exist but do not, witness stars that shoot death rays across galaxies, and visit the very edge of reality itself, where the laws of physics break down. If you want to understand what truly keeps astronomers awake at night, hit that like button and subscribe, because we're about to explore the universe's darkest secrets. Prepare yourselves. We begin. We live in a galaxy containing 400 billion stars, yet we have never received a single confirmed message from another civilization. This silence terrifies scientists more than any black hole or supernova because it suggests something deeply wrong with our understanding of life in the universe. Consider the numbers that should make alien contact inevitable. Our galaxy formed over 13 billion years ago, giving countless worlds time to develop intelligent life. Even if only 1 in a million stars hosts a technological civilization, that still means 400,000 alien societies should exist in our galaxy alone, with billions of years to spread across space. Some of these civilizations should have become so advanced that their presence would be obvious to us. Think of it like walking into a massive city that should contain millions of people, yet finding every street completely empty. The silence becomes more frightening than any noise, because it suggests something terrible happened to everyone who should be there. This puzzle has a name that makes scientists uncomfortable: the Fermi paradox. Named after physicist Enrico Fermi, who first asked the haunting question that still echoes through research labs today: where is everybody? The question seems simple, but its implications shake the foundation of our cosmic optimism. Some scientists propose that we are truly alone, the only intelligent life in a vast, empty galaxy. But an even more disturbing possibility lurks in the data. What if civilizations do develop regularly throughout the cosmos, but something stops them before they can spread to the stars? What if there exists a cosmic barrier so deadly that no technological species ever survives long enough to become visible to others? The silence might not represent emptiness. It might represent a graveyard where countless civilizations try to reach for the stars and fail. If this is true, then we are not explorers in a universe full of friends waiting to meet us. We are the next potential victims of whatever cosmic executioner has been cleaning house for billions of years. Every day we search the skies and hear nothing back. The evidence grows stronger that something out there eliminates civilizations before they can say hello. Next, we discover what this invisible destroyer might be and why it could already be hunting us. Picture a cosmic minefield where every civilization must navigate deadly obstacles to survive, but the mines are invisible and the map changes without warning. Scientists call this theoretical gauntlet the Great Filter, and it might be the most terrifying concept in all of science. The Great Filter theory suggests that somewhere between the formation of a planet and the spread of life across multiple star systems, there exists a nearly impossible challenge that destroys almost every attempt at civilization. Like a cosmic quality control system, it weeds out species before they can become truly spacefaring, leaving behind only silence and empty worlds. Think about our own path, from single-celled organisms to space-traveling humans. We survived countless extinction events, developed complex brains, learned to cooperate in massive societies, and built technology powerful enough to reach other planets. Each step required winning a cosmic lottery with odds so bad that most species never make it through. But here's what makes scientists lose sleep. We do not know if we have already passed through the Great Filter, or if we are still approaching it. If the filter lies behind us, hidden somewhere in our evolutionary past, then we might be among the rare species that successfully navigated the deadliest challenge in the universe. We could be the lucky ones who made it through alive. However, if the Great Filter still lies ahead of us, then we are walking toward our own extinction event. Every day we advance as a civilization, we move closer to encountering whatever mechanism has been silently eliminating technological species for billions of years across countless worlds. The terrifying part is that we might never see it coming. The filter could be a natural phenomenon like asteroid impacts, gamma ray bursts, or climate collapse. Or it could be something built into the nature of intelligence itself, like nuclear warfare, artificial intelligence gone wrong, or ecological destruction that every technological species inevitably brings upon itself. Consider this chilling possibility. Maybe every civilization reaches a point where it develops weapons or technologies so powerful that survival becomes mathematically impossible. Maybe intelligence itself is an evolutionary dead end that always leads to self-destruction. The silence from space might not be evidence of emptiness, but evidence of a cosmic pattern where technological civilizations always eliminate themselves just before they become visible to others. We stand at the edge of technologies that could transform us into a galaxy-spanning civilization or destroy us completely. The question that haunts every astronomer remains unanswered. Which side of the Great Filter are we on? Deep in research laboratories around the world, scientists study the remains of civilizations that never had a chance to introduce themselves. Not alien civilizations, but previous versions of life on Earth that faced their own great filters and lost everything. 99% of all species that ever lived on our planet are now extinct. These were not failures or evolutionary mistakes, but successful life forms that dominated their environments for millions of years before encountering challenges they could not overcome. If Earth itself serves as a testing ground for the Great Filter, then the evidence suggests that survival is the exception, not the rule. Look at what happened during the Permian extinction, the closest our planet ever came to becoming completely sterile. Volcanic eruptions in Siberia pumped so much carbon dioxide and toxic gas into the atmosphere that temperatures soared and oceans became acidic death traps. 96% of marine species and 70% of land species disappeared forever. Life on Earth came within a few percentage points of total annihilation. But here is what makes this extinction event relevant to the Great Filter. It was not caused by an asteroid impact or alien invasion. It was caused by the planet itself, by natural processes that spiraled out of control. If volcanic activity could nearly sterilize Earth during a time when the most complex life forms were simple animals, imagine what similar processes could do to a technological civilization that depends on stable climate and functioning ecosystems. Now consider that we might be creating our own version of the Permian extinction. Our industrial civilization pumps greenhouse gases into the atmosphere at rates that rival those ancient volcanic eruptions. We have altered the chemistry of oceans, changed weather patterns across the globe, and triggered what many scientists call the sixth mass extinction. The terrifying question becomes clear. Is environmental collapse the Great Filter that eliminates technological civilizations? Do all intelligent species inevitably modify their planets in ways that make long-term survival impossible? If so, then the silence from space makes perfect sense. Civilizations develop technology, accidentally destroy their life support systems, and vanish before they can spread to other worlds. This filter might be invisible to the civilizations experiencing it, like bacteria in a petri dish that multiply until they poison themselves with their own waste products. Technological species might be incapable of recognizing the environmental damage they cause until it becomes too late to reverse. Every measurement we take of our changing planet brings us closer to understanding whether we are passing through the filter successfully or repeating the same fatal mistake that has silenced countless other worlds. Something even more sinister might be lurking in the darkness between stars, manipulating the very structure of reality. Imagine discovering that 85% of everything that exists in the universe is completely invisible, untouchable, and utterly mysterious. This is not science fiction, but the uncomfortable reality that keeps cosmologists awake at night staring at equations that refuse to make sense. Scientists call this invisible majority dark matter, though the name understates how profoundly it challenges everything we thought we understood about reality. Dark matter does not emit light, does not absorb light, and does not interact with normal matter in any way we can detect. Yet without it, galaxies would fly apart, stars would never form, and the universe would be nothing more than a thin soup of hydrogen and helium, expanding into infinite emptiness. Think about how disturbing this revelation actually is. We have spent centuries studying physics, building equations that describe how matter behaves, and creating technologies based on our understanding of fundamental forces. Then we discover that everything we can see, touch, and measure represents only 15% of what actually exists. The other 85% operates according to rules we cannot comprehend, using physics we do not possess. Picture trying to understand a massive city by examining only the streetlights while ignoring all the buildings, people, and vehicles that make up the actual metropolis. This is essentially what human science has been doing for the entire history of our civilization. We have been studying the tiny visible portion of reality while remaining completely blind to the invisible infrastructure that holds everything together. But the truly frightening aspect of dark matter goes beyond its mysterious nature. This invisible substance exerts gravitational influence over everything in the universe, including us. Right now, as you sit reading this, dark matter particles are streaming through your body, through the Earth, through the entire solar system, without leaving any trace of their passage. We exist inside a vast network of dark matter that we cannot detect, cannot predict, and cannot control. For all we know, this invisible majority could be capable of interactions and behaviors that would terrify us if we could observe them directly. Dark matter might be undergoing processes, forming structures, or following patterns that dwarf anything we can imagine. The possibility that haunts scientists is this: what if dark matter is not just invisible cosmic scaffolding, but something far more active and intentional? What if the universe contains forms of organization and intelligence operating on scales so vast that we cannot even recognize them as alive? We might be microbes swimming in an ocean while remaining completely unaware that the ocean itself is part of something incomprehensibly larger and more complex. Even more disturbing than dark matter is the discovery of an invisible force that seems determined to tear the universe apart. Something is pushing the universe toward a fate worse than death, and we have no idea what it is or how to stop it. Astronomers discovered this cosmic destroyer by accident while trying to measure how gravity was slowing down the expansion of the universe, only to find that expansion is actually speeding up. This acceleration violates everything we thought we knew about how the universe should behave. After the Big Bang, the expansion should be gradually slowing down as gravity pulls everything back together. Instead, some mysterious force is overpowering gravity itself and forcing galaxies to race away from each other at ever-increasing speeds. Scientists named this phenomenon dark energy, though calling it energy might be misleading. Dark energy does not behave like any form of energy we have ever encountered. It does not weaken as it spreads through space, does not clump together to form structures, and does not interact with matter or light in any detectable way. Yet it makes up 70% of everything that exists and grows stronger as the universe expands. Think of dark energy as a cosmic poison that becomes more concentrated as space itself grows larger. Unlike normal substances that become diluted when spread over greater areas, dark energy maintains constant density even as new space continuously appears between galaxies. This means the total amount of dark energy in the universe increases every second, making its influence more powerful with each passing moment. The terrifying implications become clear when you follow this process to its logical conclusion. If dark energy continues strengthening as the universe expands, it will eventually overpower not just gravity between galaxies, but gravity within galaxies, within solar systems, within planets, and finally within atoms themselves. Picture the ultimate cosmic apocalypse. A time when dark energy becomes so dominant that it rips apart every structure in the universe. First, galaxy clusters would dissolve as individual galaxies flew apart. Then galaxies themselves would disintegrate as stars scattered into the void. Solar systems would break apart as planets lost their orbital bonds with their suns. Finally, even atoms would be torn apart as dark energy overcame the fundamental forces that hold matter together. This scenario has a name that perfectly captures its finality: the Big Rip. Unlike other cosmic catastrophes that might leave some remnants behind, the Big Rip would literally tear apart the fabric of space and time itself, leaving behind nothing but isolated particles flying through an ever-expanding emptiness. The most disturbing aspect of dark energy is that it appears to be accelerating this process. Current observations suggest that the Big Rip could occur in as little as 22 billion years, though the timeline remains highly uncertain because we still do not understand what dark energy actually is or whether its behavior might change. We live in a universe that seems to be actively working toward its own complete annihilation, and there might be nothing anyone can do to prevent it. But before dark energy destroys everything, we face more immediate threats from the deadliest weapons in the universe. In the time it takes you to read this sentence, somewhere in the universe, a star has just released more energy than our sun will produce in its entire 10 billion year lifetime. This energy erupts in the form of a gamma-ray burst, the most violent and destructive phenomenon known to science. Gamma-ray bursts represent the universe at its most savage. These events occur when massive stars collapse into black holes or when neutron stars collide with each other. In just a few seconds, they can outshine entire galaxies containing hundreds of billions of stars. The energy release is so intense that astronomers can detect gamma-ray bursts from galaxies over 13 billion light-years away, meaning we are seeing explosions that occurred when the universe was barely 700 million years old. Picture the most powerful nuclear weapon ever built by humans, then multiply that explosive force by a number so large it contains more than 50 zeros. This still would not equal the energy released by a single gamma-ray burst. These cosmic explosions are so powerful that they can be seen from the other side of the observable universe using telescopes no larger than a kitchen table. But the truly terrifying aspect of gamma-ray bursts is not their raw power, but their precision. Unlike supernovas that scatter energy in all directions, gamma-ray bursts focus their energy into narrow beams like cosmic flamethrowers. These beams are so tightly concentrated that they maintain their lethal intensity across distances that span billions of light-years. If a gamma-ray burst occurred in our own galaxy and pointed its beam toward Earth, the result would be instantaneous sterilization of our planet. The gamma radiation would strip away the ozone layer in seconds, exposing the surface to deadly solar ultraviolet radiation. The intense energy would also trigger chemical reactions in the atmosphere that would produce nitrogen dioxide, turning our sky brown and creating acid rain that would poison the oceans. Even worse, the initial blast of gamma radiation would only be the beginning. The particle beam following behind the gamma rays would continue bombarding Earth for hours or days, preventing any recovery of the protective ozone layer. Any life form that survived the initial radiation burst would face a planet with no protection from solar radiation and an atmosphere turned toxic. Scientists estimate that gamma-ray bursts powerful enough to affect Earth occur roughly once every few million years in our galaxy. This might sound comfortingly rare, but consider that mass extinctions in Earth's history occur roughly once every few million years. Some researchers suspect that past extinction events, including the Ordovician extinction that eliminated 85% of marine species, might have been caused by gamma-ray bursts from distant stars. The most disturbing realization is that we would never see it coming. Gamma-ray bursts travel at the speed of light, meaning the deadly radiation would arrive at exactly the same time as the light that would let us see the explosion. One flash of light in the sky, and everything dies. Every night when you look up at the stars, you are staring at thousands of potential weapons pointed directly at Earth. Recent discoveries have revealed that stars we once considered harmless neighbors could transform into planet-killing machines with almost no warning. The star that terrifies astronomers most is not some distant monster in another galaxy, but WR104, located just 8,000 light-years from Earth in the constellation Sagittarius. This star has become a ticking time bomb that could detonate at any moment, and when it does, it might end life on our planet forever. WR104 belongs to a class of stars called Wolf Rayet stars, massive objects that have burned through their nuclear fuel so quickly they have begun stripping away their own outer layers. These stars are essentially naked stellar cores, surrounded by shells of superheated gas racing outward at speeds of several million miles per hour. They represent the final death throes of the most massive stars in the universe. What makes WR104 particularly dangerous is its orientation relative to Earth. As this star spins, its rotation axis points almost directly toward our solar system. When it finally explodes in a supernova, it will likely produce a gamma-ray burst aimed straight at us like a cosmic rifle shot fired across 8,000 light-years of space. The explosion itself would be spectacular beyond imagination. For several weeks, WR104 would outshine every other star in our sky combined. During the day, it would be visible as a bright blue dot next to the sun. At night, it would cast shadows on the ground and make it possible to read books by its light alone. But the beautiful fireworks display would herald the beginning of Earth's sterilization. The gamma-ray burst would strip away our ozone layer in a matter of minutes, exposing the surface to levels of ultraviolet radiation that would kill most land plants and create a cascade of ecological collapse. The oceans would become toxic as the gamma radiation triggered chemical reactions that would poison marine ecosystems. Even more terrifying, recent computer simulations suggest that the effects would persist for years after the initial burst. The damaged atmosphere would take decades to recover, meaning that any life forms that survived the initial radiation would face a planet with a permanently altered climate and chemistry. Scientists have identified dozens of other Wolf-Rayet stars within striking distance of Earth, each one a potential planet killer waiting for its moment to explode. Some of these stars show signs of instability that suggest their detonation could occur within the next million years, which is essentially tomorrow in astronomical terms. The most disturbing aspect of this threat is its randomness. Unlike asteroid impacts that we might detect and deflect, or climate change that we might address through technology, gamma-ray bursts from dying stars are completely beyond human control. We can only watch and wait and hope that when these stellar bombs finally explode, they are pointed away from us. But even if we avoid the gamma-ray burst threat, darker predators are prowling through space, hunting for planets to devour. Hidden in the darkness between stars, invisible monsters are drifting through our galaxy like cosmic sharks, hunting for planets to destroy. These rogue black holes travel alone through space, undetected and unpredictable, carrying enough gravitational power to tear apart entire solar systems. Most black holes stay safely anchored at the centers of galaxies, where their immense gravity helps organize billions of stars into stable orbital patterns. But some black holes have broken free from these cosmic anchor points and now wander through space as solitary predators. They move silently through the galaxy at speeds of hundreds of thousands of miles per hour, leaving no trace of their passage until they encounter something to devour. Picture a black hole with the mass of 10 suns compressed into a sphere smaller than a city. Now imagine this monster traveling through space with no warning signs, no visible light, and no advance notice of its approach. It would remain completely invisible until it came close enough to start gravitationally disrupting whatever solar system happened to be in its path. Recent computer simulations suggest that our galaxy might contain millions of these rogue black holes, the remnants of massive stars that exploded as supernovas billions of years ago. When these stars died, they left behind black holes that received gravitational kicks from the asymmetric explosions, launching them on random trajectories through space like cosmic billiard balls scattered by a chaotic collision. The terrifying scenario begins when a rogue black hole approaches our solar system. Long before the black hole itself becomes visible, its gravity would start distorting the orbits of the outer planets. Neptune and Uranus would be the first to feel the pull, their orbital paths gradually bending as the invisible intruder approached. As the rogue black hole moved closer, its gravitational influence would grow stronger and more destructive. Jupiter's orbit would become unstable, causing the giant planet to either crash into the sun or be flung out of the solar system entirely. Without Jupiter's protective gravitational influence, asteroids and comets would rain down on the inner planets like cosmic hail. Mars would likely be pulled from its orbit and sent careening through space. Earth would experience massive tidal forces that would trigger global earthquakes, volcanic eruptions, and tsunamis as the planet's shape distorted under the black hole's gravitational grip. In the final stages, Earth itself would be stretched apart by tidal forces, as the front side of the planet experienced stronger gravitational pull than the backside. The solid ground would buckle and crack, the atmosphere would be stripped away, and the oceans would boil off into space. The most disturbing aspect of this threat is its stealth nature. Unlike asteroids that we can track decades in advance, rogue black holes remain invisible until they start destroying things. By the time we detected the gravitational disturbances that would signal an approaching black hole, it would already be too late to do anything except watch our solar system disintegrate. Astronomers estimate that a rogue black hole passes within 1 light-year of Earth roughly once every few million years, close enough to disrupt planetary orbits throughout our solar system. We live in a cosmic shooting gallery where the bullets are invisible and travel for millions of years before finding their targets. Right now, several rogue black holes might be moving through our solar system, and we would have no way of knowing until they started tearing planets apart. This terrifying possibility keeps astronomers searching the skies for gravitational ghosts that reveal themselves only when they begin destroying the worlds they encounter. The challenge of detecting rogue black holes represents one of the most difficult problems in astronomy. Unlike stars that shine with their own light or planets that reflect sunlight, black holes are essentially holes in space that swallow every photon that comes too close. They can only be found when they interact gravitationally with other objects, creating detectable disturbances in the motion of nearby stars or planets. Think about trying to find an invisible predator, stalking through a dark forest by watching for disturbed leaves and broken branches. This is essentially what scientists must do to locate rogue black holes. They search for stars that wobble mysteriously, planetary orbits that deviate from predicted paths, and gravitational lensing effects that bend light from background objects. Recent discoveries have made this problem even more disturbing. Astronomers have found evidence of rogue black holes passing through distant star systems, leaving behind trails of destruction that tell the story of their passage. In some cases, these cosmic predators have completely ejected planets from their orbits, sending entire worlds flying through space as orphaned refugees with no star to call home. One particularly chilling discovery involves a star system where a rogue black hole appears to have passed through the orbital plane of several planets. The gravitational disturbance was so severe that it flung multiple worlds out of the system entirely, leaving behind only a single surviving planet in a highly eccentric orbit that takes it from scorching heat to frozen emptiness with each revolution around its star. But the most terrifying realization is that our current detection methods can only find rogue black holes that are actively interacting with visible matter. A black hole traveling through empty space between star systems would remain completely invisible to our telescopes until it wandered close enough to gravitationally disrupt something we can observe. Scientists estimate that millions of these invisible destroyers could be moving through our galaxy right now, following random paths determined by gravitational encounters that occurred billions of years ago. They travel like cosmic bullets fired in ancient battles, carrying enough energy to devastate any planetary system unlucky enough to intersect their trajectories. The mathematics of orbital mechanics suggest that Earth has probably been approached by rogue black holes multiple times throughout its history. Most would have passed far enough away to avoid major disruption, but some encounters might have been close enough to trigger climate changes, mass extinctions, or other catastrophic events that left no clear evidence of their cosmic cause. Every few million years, our solar system rolls the dice in a cosmic lottery where the prize is continued existence and the penalty is complete annihilation. The game continues whether we are paying attention or not, and the next roll could come at any moment. Ahead lies something even more final than black holes: the ultimate death of everything that exists. Imagine a future so distant that every star in the universe has burned out. Every black hole has evaporated, and every atom has decayed into nothing but scattered particles drifting through an endless, empty, and eternally expanding void. This is not science fiction, but the inevitable fate that awaits everything that exists, according to our best understanding of physics. Scientists call this ultimate ending the heat death of the universe, though the name understates the absolute finality of what it represents. Heat death means that all energy in the universe will eventually become evenly distributed, leaving no temperature differences to drive any form of activity, life, or change. It will be the end not just of stars and planets, but of time itself as a meaningful concept. The countdown to this cosmic finale has already begun. Every second, the universe grows larger and colder, as space itself expands and the energy from the Big Bang spreads across ever greater volumes. Stars continue burning their nuclear fuel, converting matter into energy that radiates away into space and can never be recovered. With each fusion reaction in every star, the universe moves one tiny step closer to its final equilibrium. Think about what heat death actually means for everything we consider important. Every human achievement, every work of art, every moment of love or discovery or triumph will eventually be erased as completely as if they never happened. The pyramids, the symphonies of Mozart, the footprints on the moon, and the entire story of human civilization will vanish without leaving any trace in the final state of maximum entropy. But the terrifying timeline stretches far beyond human extinction. Long after our species disappears, stars will continue shining for trillions of years, gradually burning through all available hydrogen and helium until nuclear fusion becomes impossible anywhere in the universe. Red dwarf stars, the smallest and longest-lived, will continue glowing for up to 100 trillion years before finally flickering out and leaving behind cold, dark remnants. Even after the last star dies, the universe will not be empty. Black holes will remain, slowly evaporating through Hawking radiation over timescales so vast that the current age of the universe represents less than a single second compared to the time it will take for the largest black holes to completely disappear. The final phase will last longer than all previous phases combined. After every black hole has evaporated, the universe will contain only isolated particles scattered across distances so vast that they will almost never encounter each other. These particles will continue drifting through space for periods of time that dwarf the imagination, occasionally forming random structures through quantum fluctuations before dissolving back into chaos. Eventually, even protons themselves might decay, leaving behind only photons, neutrinos, and other stable particles spreading through a space so large that the distance between any two particles exceeds the current size of the observable universe. The most disturbing aspect of heat death is its absolute inevitability. Unlike other cosmic catastrophes that might be avoided through technology or luck, the heat death of the universe follows directly from the fundamental laws of physics as we understand them. We live in a universe that is not just temporary, but systematically destroying itself through its own expansion and the irreversible conversion of useful energy into waste heat. Next, we discover an even more immediate threat, a bubble of destruction that could end everything in our local region of space at any moment. The death of our universe will not happen all at once, but will unfold as a slow-motion apocalypse spanning trillions of years, with each phase more desolate than the last. To understand how utterly alone we will become, we must follow the timeline of stellar death from the first dying stars to the final flicker of light in an ever-expanding void. In roughly 5 billion years, our own sun will begin its death throes, swelling into a red giant that will engulf Mercury, Venus, and possibly Earth itself. But this represents just the opening act in a cosmic tragedy that will continue for timeframes that dwarf the entire history of life on our planet. The Sun belongs to a middle-aged generation of stars that will burn brightly for about 10 billion years before exhausting their nuclear fuel. Think about the most long-lived stars in our galaxy, the tiny red dwarf stars that burn their fuel so slowly they could theoretically shine for 100 trillion years. These stellar marathoners will be the last sources of light in a universe that grows darker with each passing billion years. Even after our sun dies, even after massive stars have long since exploded as supernovas, these faint red embers will continue glowing in the cosmic darkness. But mathematics is unforgiving, and even the most efficient stars cannot burn forever. In 100 trillion years, the last red dwarf star will exhaust its hydrogen fuel and fade into a cold, dark remnant. This moment will mark the end of the stelliferous era, the age of star formation and stellar burning that has defined the character of our universe for over 13 billion years. After the last star dies, the universe will enter what astronomers call the degenerate era, dominated by the slowly cooling remnants of dead stars. White dwarf stars, neutron stars, and black holes will represent the only organized matter in a cosmos that has become incomprehensibly cold and empty. These stellar corpses will continue to exist for timescales so vast that the current age of the universe represents less than a single heartbeat compared to the eternity that stretches ahead. Even more disturbing is what happens to the matter that once formed planets, comets, and living beings. As the universe continues expanding and cooling, all complex structures will gradually decay. Planets will be torn apart by tidal forces, their atoms scattered across ever greater volumes of space. The very concept of solid matter will become meaningless in a universe where individual particles are separated by distances larger than galaxies are today. The timeline of cosmic death stretches so far into the future that our minds cannot truly grasp its scale. If the current age of the universe were compressed into a single second, the death of the last star would not occur until after 37 million years had passed. Everything we consider permanent and eternal represents just the first instant of a story that will continue for periods of time that render human existence invisible. We live during the universe's brief moment of warmth and complexity, surrounded by light and life that will never exist again once the stellar fires burn out. But before we reach this distant future, reality itself might be destroyed by a phenomenon that could erase everything instantly. The empty space around you right now might be the most dangerous substance in the universe. What we call empty vacuum is actually seething with invisible energy fields that determine the fundamental properties of matter, time, and space itself. If physicists are correct about a terrifying possibility called vacuum decay, then every cubic inch of seemingly empty space could spontaneously transform into a reality-destroying bubble that would erase everything we know. Most people think of vacuum as simple nothingness, but quantum physics reveals that empty space is actually filled with energy fields that give particles their mass, determine the strength of fundamental forces, and define the basic rules that govern how reality operates. These fields exist in what physicists call a ground state, the lowest possible energy configuration that allows our universe to remain stable. But here's what keeps theoretical physicists awake at night. Our universe's vacuum might not be sitting in the true ground state. Instead, we might be trapped in what scientists call a false vacuum, a temporary energy configuration that feels stable but could collapse at any moment into a lower energy state. Think of it like a boulder, balanced on a hillside that appears motionless, but could suddenly roll downhill if disturbed by even a tiny push. If our vacuum is indeed false, then somewhere in the universe, a small region of space might spontaneously tunnel into the true vacuum state. This would create a bubble of true vacuum that would expand outward at the speed of light, destroying everything in its path and rewriting the laws of physics as it spreads. The bubble would be completely invisible as it approached, giving no warning of its arrival. Inside the bubble, the fundamental constants that govern how atoms hold together would have different values. Electrons would bind to atomic nuclei with different strengths, making chemistry impossible. The forces that hold protons and neutrons together might weaken, causing atomic nuclei to disintegrate. Matter as we know it would simply cease to exist. Picture a sphere of altered reality expanding through space like a cosmic infection. Stars caught inside the bubble would not explode or collapse, but would simply dissolve as their constituent atoms lost the ability to remain bound together. Planets would evaporate as the electromagnetic forces that give solid matter its structure change to new values that cannot support complex chemistry. The most terrifying aspect of vacuum decay is that it would happen without any external cause. Quantum mechanics allows for the possibility that vacuum fields could spontaneously fluctuate into lower energy states purely by chance. The probability of this happening in any given region of space is incredibly small, but the universe contains so many regions that the overall likelihood becomes uncomfortably high over cosmic timescales. Even worse, high-energy events like particle collisions in cosmic rays or laboratory experiments might trigger vacuum decay artificially. Some physicists worried that experiments at the Large Hadron Collider could accidentally create the conditions needed to nucleate a true vacuum bubble, though calculations suggest this risk is extremely small. The mathematics of vacuum decay predict that once a true vacuum bubble forms, nothing can stop its expansion. It would grow at the speed of light, consuming galaxies, galaxy clusters, and eventually the entire observable universe. From inside the bubble, the expansion would be undetectable until the moment it arrived and instantly rewrote the laws of physics. We might be living in a universe that is fundamentally unstable, where the vacuum state that allows our existence could collapse without warning and erase everything that has ever existed. The bubble might already be racing toward us through space, invisible and unstoppable. Picture a sphere of destruction expanding through space at 186,000 miles per second, erasing entire galaxies as it passes through them and leaving behind a universe where the laws of physics have been rewritten. This is not a physical explosion, but something far more terrifying: the propagation of a vacuum decay bubble that would end reality as we know it. The bubble would be perfectly spherical, expanding at exactly the speed of light with mathematical precision. From outside, it would appear as a growing sphere of nothingness, a region where light itself behaves differently, and familiar forms of matter cannot exist. The boundary between our universe and the altered reality inside the bubble would be sharper than any physical surface, representing a transition between two completely different sets of natural laws. As the bubble approaches a galaxy, nothing would seem unusual until the moment it arrives. Stars would continue shining, planets would continue orbiting, and any civilizations would continue their daily activities without any awareness of their impending annihilation. The bubble travels at light speed, which means no information about its approach could reach potential victims any faster than the destruction itself. Think about what would happen when the bubble's edge reaches a star system. The boundary would pass through space like an invisible wall, instantly changing the fundamental properties of everything it touches. In the first microsecond, the electromagnetic force that holds atoms together would shift to a new strength. Electrons would spiral into atomic nuclei, or fly away completely, depending on how the new physics operates. Chemical bonds would break simultaneously throughout the affected region, as molecules lose their ability to remain stable under the altered laws of physics. DNA would unravel not through heat or radiation, but because the quantum forces that hold its double helix structure together would cease to operate according to familiar rules. Every living thing would die instantly, not from any external attack, but because the physics that allows life to exist would simply stop working. Rocky planets would not explode or melt, but would dissolve as the atomic forces that give solid matter its structure change to new values. The iron cores of planets might become unable to hold together as the strong nuclear force that binds protons and neutrons shifts to a different strength. The materials that make up mountains, oceans, and continents would simply cease to exist in any recognizable form. Stars caught in the bubble would face an even stranger fate. Nuclear fusion might become impossible under the new physics, causing stellar cores to collapse not because they ran out of fuel, but because the fundamental forces that make fusion possible would operate according to different rules. Alternatively, fusion might become so efficient that stars would burn through their fuel in seconds, triggering explosions unlike any supernova ever observed. The most disturbing aspect of vacuum decay is that we cannot predict what physics would operate inside the bubble. The new universe might be completely empty, incapable of supporting any form of complexity or structure. Or it might contain entirely different types of matter and energy that follow alien rules we could never comprehend. The bubble would continue expanding forever, consuming galaxy after galaxy until it had processed the entire observable universe. From inside the bubble, the expansion would be undetectable, because space, time, and matter would all operate according to the new physics that makes measurement impossible. We live in a universe where a single quantum fluctuation could trigger the end of everything we understand about reality. Closer to home, our own star harbors a fury that could destroy civilization in minutes. The sun that warms your face and powers all life on Earth is actually a barely controlled nuclear explosion held together by gravity, and sometimes that control slips in ways that could end our technological civilization in a matter of minutes. Hidden beneath the sun's peaceful appearance is a magnetic monster capable of unleashing energy bursts that would make nuclear weapons look like fireflies. Every 11 years, the sun's magnetic field becomes increasingly twisted and unstable as magnetic field lines tangle together like cosmic spaghetti. These magnetic disturbances build up enormous amounts of energy that eventually must be released through events called solar flares, explosions so powerful they can be seen from Earth as brilliant flashes of light erupting from the sun's surface. Think of the sun as a massive pressure cooker, where magnetic forces build up stress until something has to give. When magnetic field lines suddenly snap and reconnect, they release energy equivalent to billions of nuclear bombs exploding simultaneously. The most powerful solar flares can unleash more energy in 20 minutes than all of humanity uses in an entire year. But solar flares represent only the beginning of our sun's destructive potential. The real threat comes from what scientists call coronal mass ejections, massive bubbles of plasma and magnetic field that the sun hurls into space at speeds of several million miles per hour. These plasma clouds can be larger than Jupiter and carry enough energy to disrupt planetary magnetic fields across the entire solar system. The most terrifying aspect of solar storms is their unpredictability. The sun can transition from complete calm to explosive violence within minutes, giving us almost no warning before potentially civilization-ending events begin racing toward Earth. Unlike asteroid impacts that we can track years in advance, solar storms appear suddenly and travel so fast that we typically have only a few hours to prepare for their arrival. Historical records reveal that truly massive solar storms occur roughly once every few centuries, powerful enough to cause widespread technological disruption across the entire planet. The most famous example, the Carrington event of 1859, was so intense that telegraph systems around the world failed, with some operators receiving electric shocks from their equipment. Telegraph lines sparked and started fires, while the northern lights appeared as far south as the Caribbean. But the 1859 event occurred during a time when human technology was relatively simple. Telegraph systems represented the most advanced electronics of their era, and their failure caused inconvenience rather than catastrophe. Today, our civilization depends on technologies that are far more sensitive to electromagnetic disruption and far more critical to our survival. Modern power grids, satellite navigation systems, internet infrastructure, and electronic banking all use components that could be permanently damaged by the intense electromagnetic pulses generated by extreme solar storms. A Carrington-level event today would not just cause temporary blackouts, but could destroy the transformers and microprocessors that our technological civilization requires to function. The sun's magnetic field operates on cycles that we still do not fully understand, making it impossible to predict when the next extreme solar storm will occur. Solar maximum periods, when flare activity peaks, happen roughly every 11 years. But the most dangerous events appear to follow longer cycles that span decades or centuries. We live on a planet orbited by a star that periodically releases energy bursts powerful enough to strip away our technological infrastructure and leave us stranded in a world that has forgotten how to function without electricity. The next solar superstorm could arrive tomorrow, and we would have less than a day to prepare for the collapse of everything that makes modern life possible. Imagine waking up one morning to discover that every electronic device in your home has been permanently destroyed. Power grids across entire continents have failed, and the satellites that enable GPS navigation, internet communication, and weather forecasting have all been fried by an invisible wave of energy from our own sun. When a massive coronal mass ejection reaches Earth, it does not arrive quietly. The first sign would be a sudden, intense display of northern lights, visible far south of their normal range, as the plasma cloud collides with our planet's magnetic field. But this beautiful light show would herald the beginning of a technological apocalypse that could last for months or years. The electromagnetic pulse generated by an extreme solar storm would induce powerful electrical currents in any conductor longer than a few feet. Power lines, which act like giant antennas stretched across hundreds of miles, would become conduits for electrical surges thousands of times stronger than normal operating voltages. The massive transformers that regulate electricity flow across power grids would overload and burn out, creating cascade failures that would bring down entire electrical networks. Think about what happens when your neighborhood loses power for a few hours. Then multiply that disruption by a factor of thousands and extend it across multiple continents for potentially years. Without electricity, water treatment plants would stop functioning, sewage systems would fail, hospitals would lose life support equipment, and food distribution networks would collapse as refrigeration systems shut down permanently. The economic impact would be catastrophic beyond imagination. A study by the National Academy of Sciences estimated that an extreme solar storm hitting North America could cause damage exceeding $2 trillion, with recovery times measured in years rather than months. The interconnected nature of modern infrastructure means that failures cascade from one system to another, creating disruptions that amplify far beyond the original damage. But the most terrifying aspect of a solar superstorm would be the destruction of satellites in orbit around Earth. The radiation and charged particles from the coronal mass ejection would overwhelm the electronics on hundreds of satellites simultaneously, leaving us without GPS navigation, satellite communication, weather monitoring, or the internet backbone that modern civilization requires to function. Air travel would become impossibly dangerous without GPS guidance systems. Ships would lose their ability to navigate precisely across oceans. Emergency services would lose the communication networks they depend on to coordinate responses to disasters. Financial markets would collapse as electronic trading systems failed and banks lost the ability to process transactions. The damage would not be temporary. Unlike a power outage caused by a fallen tree that can be repaired in hours, the transformers and satellite components destroyed by a solar superstorm would need to be manufactured and replaced. These systems are so complex and specialized that rebuilding them could take years, especially if the manufacturing facilities that produce them were also damaged by the same electromagnetic event. Perhaps most disturbing, our increasing dependence on technology makes us more vulnerable to solar storms with each passing year. The electrical grids of 50 years ago were simpler and more robust, capable of surviving electromagnetic disruptions that would cripple modern smart grids filled with sensitive computer systems. We have built a civilization that becomes more fragile as it becomes more advanced, creating millions of points of failure that could all be triggered simultaneously by a single burst of energy from our seemingly peaceful sun. The next extreme solar storm is not a matter of if, but when. And our technological civilization hangs by a thread that could be severed at any moment. Beyond solar fury, chunks of rock and ice patrol the space around our planet, some large enough to end civilization as we know it. Right now, over 28,000 asteroids larger than a football field are following orbital paths that could eventually intersect with Earth, and we have only discovered and tracked about half of them. These cosmic bullets travel through space at speeds that would make a rifle shot look motionless, carrying enough kinetic energy to obliterate cities or trigger global climate disasters that could end human civilization. The asteroid that killed the dinosaurs 66 million years ago was roughly 6 miles across, about the size of a small mountain. When it slammed into the Yucatan Peninsula at 43,000 miles per hour, it released energy equivalent to several billion nuclear weapons detonating simultaneously. The impact created a crater over 90 miles wide and triggered earthquakes, tsunamis, and volcanic eruptions across the entire planet. But the immediate destruction was only the beginning. The impact threw so much dust and debris into the atmosphere that sunlight was blocked for months, causing global temperatures to plummet and photosynthesis to shut down worldwide. Plants died, herbivores starved, and carnivores followed them into extinction. Over 75% of all species on Earth disappeared in what scientists call the most recent mass extinction event. Think about what an asteroid impact would mean for our technologically dependent civilization. Unlike the dinosaurs, who lived in small, scattered populations that could survive on whatever food sources remained available, humans have concentrated into massive cities that require constant supply chains to feed their populations. A global climate disaster triggered by an asteroid impact would collapse agriculture worldwide, creating famine conditions that could kill billions of people within months. The terrifying reality is that we do not need a dinosaur killer asteroid to end civilization. An object just half a mile across would be enough to trigger global climate disruption through the dust and debris it would throw into the atmosphere. Such an impact would release energy equivalent to 100,000 nuclear weapons, creating an explosion visible from space and a fireball that would incinerate everything within hundreds of miles. Even smaller asteroids pose existential threats to our interconnected world. The object that exploded over Tunguska, Siberia, in 1908 was only about 200 feet across, yet it flattened over 800 square miles of forest with the force of 1,000 nuclear bombs. If a similar object exploded over a major city today, it could kill millions of people and trigger economic disruptions that would cascade around the globe. NASA and other space agencies have identified over 2,000 potentially hazardous asteroids that could pose threats to Earth, but new ones are discovered regularly as our detection capabilities improve. The most disturbing discoveries involve asteroids that approach from the direction of the Sun, making them nearly impossible to spot until they have already passed close to our planet. Some asteroids follow highly elliptical orbits that bring them near Earth only once every few centuries or millennia, meaning they could remain undetected until just weeks or months before impact. These cosmic stealth weapons travel through the outer solar system for decades, building up speed as they fall toward the Sun, before racing past Earth's orbit at velocities that would make deflection extremely difficult. The mathematics of orbital mechanics reveal that Earth exists in a cosmic shooting gallery, where impacts are not rare accidents but regular occurrences stretched across geological time. Major impacts capable of causing global disruption occur roughly once every few million years, while smaller city-destroying events happen once every few centuries. We live on a target in space, surrounded by ammunition that has been accumulating for billions of years. The next shot could come from a direction we are not watching, traveling too fast to stop. But asteroids are not the only projectiles aimed at our planet from the depths of space. In the frozen darkness beyond Neptune, millions of ancient ice balls wait in a vast spherical cloud that surrounds our solar system like a cosmic minefield. These comets have been hibernating for billions of years, but gravitational disturbances can send them racing toward the inner solar system at speeds that make asteroids look slow and predictable. Long-period comets represent the most dangerous projectiles in our cosmic neighborhood because they approach from completely random directions and give us almost no warning before potential impact. While asteroids follow predictable orbits that allow astronomers to calculate their paths decades in advance, comets can be nudged out of the distant Oort cloud by passing stars or gravitational waves, sending them on collision courses that remain invisible until they are already racing toward Earth. Think about the physics of what happens when a comet begins its journey from the outer edge of our solar system. Starting from a distance of over 50,000 times farther from the Sun than Earth, these frozen mountains accelerate under solar gravity for months or years, building up velocities that can exceed 100,000 miles per hour by the time they reach the inner solar system. The speed difference makes comets far more destructive than asteroids of similar size. While a typical asteroid might impact Earth at 30,000 miles per hour, a comet arriving from the Oort cloud could strike at twice that velocity, quadrupling its kinetic energy and devastating potential. The faster an object moves, the more catastrophic its impact becomes, following the unforgiving mathematics of kinetic energy that increases with the square of velocity. But speed is not the only factor that makes comets terrifying. Unlike rocky asteroids that remain solid as they approach the sun, comets begin sublimating as they warm up, creating massive tails of gas and debris that can stretch for millions of miles. If Earth passed through the tail of a large comet, our planet would be bombarded with high-velocity particles and toxic gases that could strip away our ozone layer and poison our atmosphere. The most disturbing aspect of comet threats is their unpredictability. Astronomers estimate that the Oort cloud contains over 1 trillion comets, but we have no way of knowing which ones might be disturbed and sent toward the inner solar system. A passing star, a rogue planet, or even galactic tidal forces could destabilize thousands of comets simultaneously, creating a cosmic bombardment that would overwhelm any planetary defense system. Historical records suggest that major comet impacts have triggered some of the most severe climate disruptions in Earth's history. The impact that created the Chesapeake Bay crater 35 million years ago might have been caused by a comet, and the resulting climate changes contributed to a mass extinction event that eliminated many species of marine life. Even more terrifying, some comets follow such elongated orbits that they remain invisible to our telescopes until they are already approaching the inner solar system. These stealth comets could appear in our skies with only months or weeks of warning, far too little time to mount any meaningful defense effort. The largest known comet, Hale-Bopp, has a nucleus roughly 25 miles across and follows an orbit that brings it past Earth every 4,000 years. If gravitational perturbations altered its path to intersect with our planet, the resulting impact would release energy equivalent to several million nuclear weapons and trigger climate effects that could last for decades. We live in a solar system surrounded by a shell of frozen projectiles, any of which could be launched toward Earth without warning by invisible gravitational forces operating across interstellar distances. The next comet to threaten our world might already be accelerating toward us from the darkness beyond Pluto, building up speed for an impact that could occur within our lifetimes. But even more exotic threats lurk in the depths of space, where the corpses of massive stars have become the most dangerous objects in the universe. Imagine a star so massive that when it dies, it collapses into a ball of pure neutrons only 12 miles across, but containing more matter than our entire sun. Now imagine that this stellar corpse spins 30 times per second while generating magnetic fields trillions of times stronger than anything that exists on Earth. You have just pictured a magnetar, the most violent and unpredictable object in the known universe. When the most massive stars in our galaxy exhaust their nuclear fuel, they do not fade away quietly like our sun will in 5 billion years. Instead, they explode as supernovas so violent that they briefly outshine every other star in their galaxy combined. But for the largest stars, even a supernova explosion is not enough to completely destroy them. Their cores collapse under their own gravity, until atoms themselves are crushed out of existence. The result is a neutron star, a sphere of matter so dense that a teaspoon of it would weigh as much as Mount Everest. The entire mass of a star, 1.4 times heavier than our sun, becomes compressed into a city-sized ball where the laws of physics operate under the most extreme conditions possible outside of a black hole. But some neutron stars are born with magnetic fields so intense that they transcend normal physics entirely. These magnetars possess magnetic fields quadrillions of times stronger than Earth's magnetic field, powerful enough to strip electrons from atoms at distances of hundreds of miles. The magnetic field of a magnetar is so intense that it warps the shape of atoms themselves, creating exotic forms of matter that cannot exist anywhere else in the universe. Think about what happens when such an object becomes unstable. The magnetic field lines that thread through a magnetar's crust can become twisted and tangled like cosmic cables under impossible tension. When these field lines suddenly snap and reconnect, they release energy equivalent to all the nuclear weapons ever built by humanity detonating simultaneously. These magnetic explosions, called magnetar flares, can occur without warning and release more energy in 1/10 of a second than our sun produces in 100,000 years. The most powerful magnetar flare ever recorded occurred in December 2004, When a magnetar located 50,000 light-years from Earth released so much energy that it temporarily ionized our planet's upper atmosphere and disrupted radio communications worldwide. The terrifying aspect of magnetar flares is their unpredictability. Unlike supernovas or gamma-ray bursts that occur during predictable stellar death processes, magnetar flares can happen at any time when the magnetic field of a neutron star becomes unstable. A magnetar can remain quiet for decades, then suddenly explode with energy that would sterilize any planet within hundreds of light-years. Even more disturbing, astronomers have identified several magnetars within our own galaxy that are close enough to Earth to pose potential threats. The magnetar SGR 1806-20 lies only 10,000 light-years from our solar system, close enough that a major flare could disrupt our electronics, damage satellites, and possibly affect our climate through high-energy radiation. The most powerful magnetar flare theoretically possible would release energy equivalent to a gamma-ray burst, creating a directed beam of destruction that could sterilize planets across thousands of light-years. Such an event would be visible from other galaxies and could trigger mass extinctions throughout an entire region of space. We live in a galaxy that contains the corpses of exploded stars, some of which have become magnetic time bombs that could detonate without warning and flood our solar system with lethal radiation. The next magnetar flare could come from any direction at any time, and we would have no way of predicting or preventing it. These stellar remnants possess magnetic powers that challenge our understanding of what matter can become under extreme conditions. The magnetic field surrounding a magnetar is so powerful that it would kill you instantly from a distance of 600 miles, not through heat or radiation, but by literally tearing apart the atoms in your body. To understand how impossible this level of magnetism actually is, consider that the strongest magnetic fields ever created on Earth reach about 45 Tesla, while a typical magnetar generates fields of 100 trillion Tesla. Imagine trying to comprehend a magnetic field so intense that it bends the very structure of empty space. Near the surface of a magnetar, magnetic field lines become so tightly packed that they warp the geometry of space-time itself, creating conditions where the normal rules of physics break down completely. Light traveling through these regions follows curved paths as the magnetic field distorts the fabric of reality. The magnetic field of a magnetar is strong enough to levitate any object made of normal matter, regardless of whether that object contains iron or other magnetic materials. The field induces electrical currents in any conductor, creating magnetic forces powerful enough to overcome gravity and fling objects away from the neutron star's surface at thousands of miles per second. Think about what would happen to a spacecraft that ventured too close to a magnetar. Long before reaching the neutron star itself, the intense magnetic field would begin inducing electrical currents in the metal hull. These currents would generate heat so rapidly that the spacecraft would begin glowing white-hot, then vaporize completely as the metal boiled away into plasma. Any electronic equipment would fail catastrophically as circuits overloaded and computer chips melted. But the truly disturbing aspect of magnetar magnetism is how it affects the fundamental structure of matter itself. In magnetic fields, the strong atoms become elongated into needle-like shapes as electrons are forced into narrow cylindrical orbits around atomic nuclei. Chemistry as we know it becomes impossible, because the shapes and energy levels of electron orbitals change so dramatically that familiar molecules cannot form. The magnetic field actually changes the strength of chemical bonds, making some substances harder than diamond while turning others into gases that cannot exist under normal conditions. Water molecules would be torn apart instantly, their hydrogen and oxygen atoms unable to maintain their chemical bonds in the presence of such extreme magnetism. Even more bizarre, the magnetic field of a magnetar can create matter from empty space through a quantum mechanical process that violates our everyday understanding of conservation laws. The intense magnetic field provides enough energy to spontaneously create electron-positron pairs from the vacuum, filling the space around the magnetar with exotic plasmas that behave according to physics we are only beginning to understand. The surface of a magnetar is covered with a crystalline crust made of atomic nuclei, arranged in geometric patterns unlike anything that exists elsewhere in the universe. This crystal structure is held together by magnetic forces so powerful that it forms the strongest solid material known to science, harder than any substance that could exist on Earth by factors of billions. When this magnetic crystal crust cracks under the immense stresses created by the neutron star's magnetic field, it triggers the magnetar flares that can release more energy than our Sun produces in millennia. The crack propagates through the crystal structure at nearly the speed of light, causing magnetic field lines to snap and reconnect with explosive violence. We live in a universe where the death of massive stars creates magnetic monsters so extreme that they rewrite the laws of physics in their immediate vicinity, creating pockets of reality where matter, energy, and space itself behave according to alien rules. These magnetic fields possess the power to reach across interstellar space and destroy worlds with invisible forces that operate beyond our ability to comprehend or control. When a magnetar unleashes its fury, it does not simply explode like a bomb or emit radiation like a star. Instead, it tears apart the fundamental forces that hold atoms together, creating a wave of destruction that can sterilize planets across thousands of light years and leave behind matter that no longer obeys the familiar laws of chemistry and physics. The December 2004 magnetar flare that reached Earth from 50,000 light-years away released more energy in 1/10 of a second than our Sun will produce in the next 100,000 years. This explosion was so powerful that it temporarily changed the shape of our planet's magnetic field, ionized the upper atmosphere, and disrupted radio communications across the entire globe. Think about what this means for our understanding of cosmic threats. An event that lasted less than a second and occurred at a distance of 50,000 light-years was still powerful enough to affect our entire planet. If that same magnetar had been located just 1,000 light-years from Earth, the energy burst would have been 2,500 times more intense, potentially stripping away our ozone layer and triggering a mass extinction event. The radiation from a nearby magnetar flare would not kill life on Earth through heat or visible light, but through high-energy gamma rays that penetrate deep into living tissue and shatter the molecular bonds that hold DNA together. Unlike solar radiation that affects only the surface of our planet, gamma rays from a magnetar would penetrate through our atmosphere and reach all the way to the ocean floor, sterilizing the entire biosphere simultaneously. But the immediate radiation burst would only be the beginning of a magnetar-triggered apocalypse. The intense energy would split nitrogen and oxygen molecules in our atmosphere, creating nitrogen oxides that would destroy the ozone layer and turn our sky brown with poisonous smog. The chemical reactions, triggered by the radiation, would continue for months after the initial burst, preventing the atmosphere from recovering its protective properties. Even more terrifying, the magnetic field disturbances created by a powerful magnetar flare could affect the atomic structure of matter throughout our solar system. The oscillating magnetic fields would induce electrical currents in any conductor, potentially overloading every electronic device on Earth simultaneously and creating electromagnetic pulses that would make solar storms look gentle by comparison. The magnetic wave from a nearby magnetar flare would also interact with Earth's magnetic field in ways that could trigger geological instabilities. The sudden changes in magnetic field strength could affect the movement of molten iron in our planet's core, potentially altering the strength and orientation of Earth's magnetic field for centuries or millennia. Scientists have calculated that magnetar flares powerful enough to cause mass extinctions on Earth occur roughly once every few million years within our galaxy. This timeline corresponds closely with the frequency of mass extinction events in the fossil record, suggesting that some of Earth's great dyings might have been caused by magnetar flares from distant neutron stars. The most disturbing aspect of magnetar threats is their complete unpredictability. Unlike supernovas that give us advance warning as massive stars approach their final collapse, magnetar flares can occur at any time when the magnetic field of a neutron star becomes unstable. A magnetar can remain quiet for decades, then suddenly explode with energy that floods our solar system with lethal radiation. We have identified several magnetars within our own galaxy that are close enough to pose potential threats, but we have no way of predicting when they might flare or how powerful their explosions might be. These stellar corpses represent loaded weapons pointed at our planet, and we can only hope that their triggers remain stable long enough for our species to spread to other star systems. The next magnetar flare could come from any direction at any time, and the first sign of its approach would be the lethal radiation itself arriving at the speed of light. Beyond even magnetars lies a cosmic nightmare so extreme that it would unravel the very fabric of space and time. Imagine a future where the expansion of the universe becomes so violent that it tears apart not just galaxies and planets, but atoms, subatomic particles, and eventually space and time themselves. This is not science fiction, but a real possibility called the Big Rip, the most extreme cosmic death scenario that physics can predict. The Big Rip would represent the ultimate triumph of dark energy over every other force in the universe. As space continues expanding at an accelerating rate, dark energy would eventually become so dominant that it overpowers gravity, electromagnetism, and even the strong nuclear force that holds atomic nuclei together. Reality itself would be stretched apart until nothing familiar could exist. Think about how this cosmic apocalypse would unfold across time. First, the acceleration of cosmic expansion would overcome the gravitational bonds that hold galaxy clusters together. Galaxies would begin flying apart from each other at ever-increasing speeds, isolated in an expanding void that grows larger every second. Within individual galaxies, the expansion would continue accelerating until it overpowered the gravity that holds stars in orbit around galactic centers. Our Milky Way would dissolve as hundreds of billions of stars scattered into the emptiness, each one racing away from all the others at velocities that increase without limit. As the expansion accelerated further, it would begin affecting individual solar systems. The gravity that keeps planets in orbit around their stars would become insufficient to resist the stretching of space itself. Earth would be torn away from the sun and flung into the cosmic void, followed by every other planet in our solar system. But the destruction would not stop at the planetary level. Once space expanded rapidly enough to overcome chemical bonds, molecules would be ripped apart as atoms lost their ability to remain connected to each other. The water in Earth's oceans would disintegrate into hydrogen and oxygen, while the carbon-based molecules that form all living tissue would dissolve into their component atoms. In the final moments before the Big Rip, even atoms themselves would be destroyed. The electromagnetic force that holds electrons in orbit around atomic nuclei would become too weak to resist the expansion of space. Electrons would be stripped away from atoms, leaving behind naked nuclei that would themselves disintegrate as the strong nuclear force finally succumbed to the cosmic stretching. The very last stage would involve the destruction of space and time themselves. As the expansion rate approaches infinity, the concept of distance becomes meaningless because every point in space would be moving away from every other point at infinite velocity. Time itself would cease to function as a meaningful dimension because causality breaks down when information cannot travel between locations that are separating at faster than light speeds. Current observations suggest that the Big Rip could occur in approximately 22 billion years, though this timeline depends on the precise behavior of dark energy, which remains one of the greatest mysteries in physics. If dark energy continues strengthening as the universe expands, the Big Rip becomes inevitable. If dark energy weakens or changes character, other cosmic death scenarios become more likely. The most disturbing aspect of the Big Rip is its absolute finality. Unlike other cosmic catastrophes that might leave some remnants behind, the Big Rip would erase everything that has ever existed and make it impossible for anything to exist again. There would be no atoms to form new matter, no space for energy to occupy, and no time for any process to occur. We live in a universe that might be systematically destroying itself through its own expansion, racing toward a moment when reality itself ceases to exist. The countdown to this ultimate ending has already begun, and every second brings us closer to the moment when space and time tear themselves apart. To understand how the Big Rip would destroy reality, imagine space as a flexible fabric that can be stretched like rubber. Now picture that fabric being pulled apart so violently that it tears into pieces, creating holes where the concept of distance becomes meaningless and causality itself breaks down. This is what happens when cosmic expansion accelerates beyond the limits that space and time can withstand. The breakdown would begin with the collapse of our ability to measure anything. Distance depends on the stability of space between 2 points, but during the Big Rip, space would be expanding so rapidly that the concept of a fixed distance would become impossible to define. A ruler that measures 1 foot today would measure infinite length tomorrow, not because the ruler changed, but because space itself expanded faster than any measurement could be completed. Think about what this means for the fundamental laws of physics. Every equation that describes how the universe operates depends on our ability to define positions, velocities, and time intervals. When space expands at infinite rates, these concepts lose all meaning. The speed of light, which serves as the universal speed limit, becomes irrelevant when space itself expands faster than light can travel through it. Communication between any 2 points in space would become impossible during the final stages of the Big Rip. Light signals traveling from one location to another would be stretched by the expanding space until their wavelengths became infinitely long and their energy dropped to zero. Information could no longer flow between different regions of the universe, isolating every point in space from every other point. The mathematics of the Big Rip predict that the expansion rate would approach infinity at a specific moment in time, creating what physicists call a finite time singularity. Unlike the singularities inside black holes, which are hidden behind event horizons, the Big Rip singularity would occur everywhere in space simultaneously, making it impossible to escape or avoid. As the expansion approaches infinite rates, the very concept of matter becomes meaningless. Particles that exist at specific locations in space would find themselves in a reality where location itself no longer makes sense. The quantum fields that give particles their properties would be stretched beyond recognition, potentially causing the fundamental forces of nature to simply stop working. Even more bizarre, the Big Rip might create regions of space where time flows backward or stops completely. The extreme curvature of spacetime during the final expansion could create causal loops where effects precede their causes, or temporal zones where the sequence of events becomes scrambled beyond recognition. The event horizon of the Big Rip would shrink rapidly as the moment of infinite expansion approaches. First, light from distant galaxies would be redshifted beyond visibility as space expanded faster than photons could travel. Then stars within our own galaxy would disappear from view as the expansion overcame the speed of light on smaller scales. Finally, even nearby objects would vanish as space expanded so rapidly that light could not travel between them. In the final seconds before the Big Rip, space would be expanding so fast that atoms on opposite sides of a single proton would be moving away from each other at faster than light speeds. The concept of a particle having a definite size would become meaningless because different parts of the same particle would exist in causally disconnected regions of spacetime. The moment of the Big Rip itself would last zero time and occur everywhere simultaneously. Space would transition from expanding at nearly infinite rates to simply not existing, leaving behind nothing that could be called a place or a moment. There would be no afterward, because time itself would have been destroyed along with everything else. We live in a universe where the fabric of reality might have an expiration date written into its fundamental structure. That date approaches with each passing moment, and when it arrives, even the concept of existence will cease to have meaning. In the final moments before the Big Rip, the laws of physics that have governed reality for nearly 14 billion years would simply stop working. Equations that describe how matter and energy behave would become meaningless as the fundamental constants that define our universe approach infinite values or cease to exist entirely. The breakdown would begin with the collapse of our understanding of force and motion. Newton's laws of motion depend on the concept of inertia, the tendency of objects to resist changes in their motion. But during the Big Rip, space itself would be accelerating so rapidly that inertia becomes impossible to define. Objects would not be pushed apart by any force, but would simply find themselves in a reality where the concept of staying in one place has no meaning. Think about what happens to conservation laws during the final expansion. The conservation of energy, one of the most fundamental principles in physics, requires that energy cannot be created or destroyed, only transformed from one form to another. But the Big Rip would create energy out of nothing as space expands and dark energy density remains constant, violating conservation laws on a universal scale. The speed of light, which serves as the ultimate speed limit in our universe, would become irrelevant when space itself expands faster than light can travel. This would break the fundamental connection between space and time that Einstein discovered, causing the fabric of space-time to tear apart like a piece of cloth stretched beyond its breaking point. Even more disturbing, the constants that determine the strength of fundamental forces would lose their meaning during the Big Rip. The electromagnetic force that holds atoms together depends on a constant called the fine structure constant, which has maintained the same value throughout the history of our universe. But as space expands at infinite rates, this constant would become undefined, causing chemistry and atomic physics to simply stop working. The mathematics that describe quantum mechanics would also break down during the final expansion. Quantum field theory depends on the ability to define particle interactions at specific points in space and time. When space expands faster than quantum fields can propagate, the very concept of a particle interaction becomes meaningless, and matter itself ceases to exist in any recognizable form. Perhaps most terrifying of all, the Big Rip would destroy the arrow of time that gives our universe its sense of past, present, and future. Time flows forward because entropy increases, creating a clear distinction between earlier and later moments. But during the infinite expansion, entropy would become undefined as space itself tears apart, causing time to lose its direction and meaning. The final equation of physics would be division by zero. Every law that describes how the universe operates contains terms that involve distance, time, or the density of matter and energy. When space expands at infinite rates, these terms approach zero in the denominator, making every equation in physics undefined simultaneously. In the last fraction of a second before the Big Rip, reality would exist in a state that cannot be described by any mathematics or physics we understand. The universe would be expanding so rapidly that different parts of the same fundamental particle would be causally disconnected from each other, creating a situation where the concept of identity breaks down along with everything else. The moment of the Big Rip itself would represent the ultimate boundary of scientific knowledge. Beyond that point, there would be no space for matter to occupy, no time for processes to occur, and no physical laws to govern whatever might exist. Science itself would cease to be possible because there would be no phenomena left to observe or understand. We live in a universe where the tools we use to understand reality might have built-in expiration dates, beyond which even the concept of understanding becomes meaningless. The countdown to this ultimate boundary continues with each tick of the cosmic clock, and when it reaches zero, knowledge itself will vanish along with everything else. But are we already seeing signs that this cosmic destruction has begun? Right now, as you read these words, telescopes around the world are detecting evidence that every cosmic nightmare we have explored might already be unfolding. The expansion of the universe is accelerating faster than ever before. Gamma-ray bursts are occurring with increasing frequency, and the silence from space grows more ominous with each passing day. The most disturbing observations come from studies of cosmic expansion itself. When astronomers measure the rate at which distant galaxies are moving away from us, they find that the acceleration is not constant, but appears to be increasing over time. This suggests that dark energy is becoming more powerful, pushing us closer to scenarios like the Big Rip, where expansion eventually overcomes all other forces in the universe. Think about what this acceleration means for our cosmic neighborhood. The local group of galaxies, which includes the Milky Way and Andromeda, is currently held together by gravity, despite the expansion of space. But as dark energy continues strengthening, even these gravitational bonds will eventually be overcome, leaving our galaxy isolated in an ever-expanding void. Recent surveys of nearby stars have revealed that magnetar candidates are more common than previously thought. Astronomers have identified dozens of neutron stars within our galaxy that show signs of extreme magnetic activity, any of which could produce flares powerful enough to disrupt our planet's climate and technology. The statistical likelihood of a nearby magnetar flare has increased significantly as our catalog of these stellar time bombs has grown. Even more ominous, the rate of gamma-ray burst detections has increased dramatically as our instruments have become more sensitive. We now observe these cosmic death rays occurring roughly once per day somewhere in the observable universe, suggesting that the processes that create them are far more common than scientists originally believed. The search for extraterrestrial intelligence has yielded increasingly disturbing results as our detection capabilities have improved. Despite monitoring billions of stars across thousands of nearby galaxies, we have found no confirmed evidence of technological civilizations. The silence has become so complete that it suggests the Great Filter might be more effective at eliminating species than even the most pessimistic models predicted. Solar activity monitoring has revealed that our sun is capable of producing flares far more powerful than the historical record suggests. Analysis of ice core data and tree ring patterns indicates that extreme solar storms occur more frequently than written records indicate, with some events powerful enough to cause global technological disruption happening roughly once every few centuries. Asteroid and comet detection programs have identified thousands of potentially hazardous objects, with new discoveries occurring weekly. The more we learn about our cosmic neighborhood, the more crowded it appears with projectiles that could trigger global catastrophes. Some recently discovered asteroids follow orbits that bring them uncomfortably close to Earth on timescales measured in decades rather than centuries. Perhaps most troubling, measurements of vacuum stability suggest that our universe might indeed be in a metastable state that could collapse into a lower energy configuration. Experiments with particle accelerators have revealed that the Higgs field, which gives particles their mass, might not be in its lowest possible energy state. This raises the possibility that a vacuum decay event could occur spontaneously or be triggered by high-energy processes. Climate monitoring stations around the globe are detecting changes that suggest our planet's life support systems are becoming increasingly unstable. Rising temperatures, shifting weather patterns, and ecological disruptions indicate that Earth might be approaching environmental tipping points that could trigger irreversible changes to our atmosphere and biosphere. The cumulative evidence suggests that we live during a period of cosmic instability when multiple existential threats are converging simultaneously. The expansion of the universe is accelerating. Stellar remnants are producing increasingly powerful explosions, and our own planet is showing signs of environmental stress that could trigger civilization-ending changes. We might be witnessing the beginning of the end times for not just our species, but for the stable cosmic environment that has allowed life to flourish throughout the universe. The question is not whether these threats will eventually destroy us, but which one will arrive first, and whether we have enough time to prepare for any of them.